This is Olympia High School in Olympia, Washington, and it's the Lunar Camper team.
Okay, so here's our prototype. It's made out of cardboard and a few pipe cleaners to hold it together. I'm not sure.
Yep, that's good. You're holding it up high.
And then,
So, this is the main body is 1.5 by 2 meters. I mean, this is obviously the model, but it's scaled to that.
Mhm.
Um, and we have, let's see, is this visible? The main portion is that these walls fold down to create extra space.
Oh,
Um, and then these, let's see, it's hard to see what's visible. Um,
no, I see it. You're pulling up something.
the walls on the sides get pulled up on tracks, and
Okay,
then
so they slide up. Okay. So
they
is
slide up.
is so okay, so they slide okay, I see it. That looks better.
Mhm.
Yes. Nice.
So they slide up and then lock at the top, which reveals the windows and the door and other components that need to have holes in the walls.
Mhm.
Um, and then the top, we wanted to keep it open so that you could see what's inside easier, but the top is going to be some sort of canvas that is kind of a tent style. It's hard to see on the camera.
Yeah, I see what you mean.
But it just goes across the top and
Mhm.
is tight in between this, and then there will be uh sort of triangles stitched to these to keep the sides, which can fold up when these walls do. And that should create enough extra space for all the internal components.
Yeah, that creates a lot of extra space.
Mhm. Oh, and there will be let's see, there'll be a support rod in between these, and maybe
Okay.
some vertical ones too to make sure
Okay.
it's rigid.
So that support rod, is it gonna be because the top goes up, so is that support rod gonna be part of the section that goes up so it follows with it?
Yes, it's going to be attached to the walls.
Okay. Yeah. No, I guess my question is it's gonna be I understand it's gonna be attached to the wall, but will it be attached to the wall that's rigid or will it be attached to the wall that moves up?
It's going to be attached to the wall that moves up.
Okay. Yeah, no, that sounds good because then you'll have that rigid structure on top. Very
Mhm.
good. And do you have an idea of how it's going to move up? Do you know the mechanism is going to be like a crank or something else?
We haven't gone that far. I'm not sure
Okay.
what material we would use. That would probably affect what method we do. But
Okay. No, that's good. I
yeah.
was just asking. That's something to think about. So that is a good answer. And that also may determine the method you use to take it up also.
Mhm.
Mhm.
Yeah,
Awesome.
we were mostly focused on the design of how it's gonna be compact and fold out to make more space with the
Yeah.
and our next phase is looking at
Okay.
materials and
Well,
these.
yeah, I like the fact that you went up. A lot of students tend to go out. So I like the fact that you did that.
Mhm.
That was cool.
Yeah, I like how it slid up. So Glenn has joined us too. And can you hold up your prototype again?
And then,
So
yeah, show how
Glenn,
it opens. Yep.
yeah.
okay. So these walls, they can go up and down. So this is the lowest here. And then they slide up.
Nice. Okay, there goes Glenn. He's just connect. Yeah, Glenn, see how yeah, show the other one how the walls slide up on these guys.
So it'll slide up on tracks and then lock at the top.
Okay.
Mhm. And the one side where the walls slide up and down, um, that would be really good for the space suit ports. You know how you have those two rectangles cut out? Show that to Glenn again.
when the walls slide up, they reveal any holes we have to have in the walls for like the soup ports or the hatch for the main lunar
So,
facility.
yeah. Hold on, I'm gonna pin you. Yeah, so and then the others go down. So and then the other side can be your windows. We don't need a door because they can't just walk out on the moon. They have to get into their space suits. So that to the other side with the spaceports is where the way they'll go in and out. But we do
Mhm.
want a window. So
Um,
does that make sense?
Yeah.
in the document, it was talking about how we need to have some sort of hatch to get into the main, like,
Yes, so that would be
yeah.
perfect. That door is to get into the main. Very good. Yeah, to get into the main habitat on the moon, right? So they can walk through that. Good. Um, do you have any thoughts about what you're going to put inside?
We haven't we haven't modeled it specifically, but I know there has to be the eclipse system and sleeping. We were thinking the beds would go on because there's a since it's pitched like this, the beds would go here to maximize the space that you can't stand up in.
So we can't see you, Jules,
Sorry.
as well as yeah. Move over towards
Um, Here,
Jolie.
So if the tent is pitched like this, then we wanted to put the beds like here, so then we could maximize the space that's sloped,
Hmm.
and that you can't stand up in normally, that couldn't fit other things. So we
Yep,
know the beds
that's
would go in
smart.
there, and
Yeah,
we haven't looked at the other stuff.
yeah. Well, and you don't have to 3D print all your stuff. You can make it out of cardboard,
I,
or you can
I
even
think your
go to a
audio
toy
is
store.
cutting out on our end.
My audio's cutting out. That's not good. Do you hear me all right?
I can hear you from the other room. Um,
Okay, I still hear
yeah.
you. So yeah.
You hear me, Nancy? All
Yep, I
right.
hear you okay.
It might be your computer.
Yeah, if they hear you from the other room, I'm assuming they have you turned off because it sounds like they're on several different computers.
Yeah.
Oh, this one turned off. Is this plugged in? This is not. Can you plug that back into or someone unplugged our
1 second.
Sure.
our speaker turned off. We figured it out. It was our
Testing.
speaker.
Okay.
Oh, okay,
There
good.
we go.
Okay, good.
All right.
Ah.
So yeah, so Flo, I'm gonna jump out, but no, like I said, I like your initial designs, and I gave you a couple of comments there. So all right, talk to
Okay,
you guys
thank you,
later.
Nancy.
All
Yep.
right, bye.
Bye-bye. Also you need to be aware of when you have anything sliding or opening, we need to be sure to keep the air in the camper, not have any leaks.
Mhm.
So you really your cloth roof could extend as far as it needs to make sure that that air stays in that camper.
Yeah, we were thinking the canvas would be attached to the walls that fold down and the top at all times. So then even when you open it, there's no gaps anywhere.
Awesome. Yeah, that would be really smart. And how about the wheels, or what are you thinking on using to move your camper?
We were thinking it would be pulled behind the um LTV and
Okay.
um it would be on like some sort of structure with wheels on it and then pulled by a trailer hitch that's attached to the structure.
Hmm. Good. So Glenn had some good comments earlier today about what are the requirements of those wheels, because they're not what he called driving wheels. Glenn, you want to talk a little bit about that? He might be frozen. Um, Uh,
Sure.
your voice is breaking up. Your voice is, we can't hear you. We still can't hear you. We don't hear you. Sorry. The connection isn't good. Keep talking. Maybe yeah, it's coming in. Say something, Glenn. I thought he was coming in. But anyways, because it's wheels that aren't driving the vehicle, they're just being pulled in the back. You don't need them at as wide as if they were driving wheels, or even the threads don't have to be able um grip the lunar regolith as much because it's just being pulled. Does that make sense? And
That's
Glenn
good.
even said it was more like a motorcycle wheel than, a heavy truck wheel, which is different than on Earth. You're not gonna, it's not a requirement to retract this camper. It's only expanded and keep it expanded.
Okay.
So think outside the box. I love when you think outside the box. My question to think about is, do you need wheels or something else? I don't know. I mean, you're thinking like here on Earth, you definitely need wheels. This is not going to be roads that are, paved in any manner whatsoever. So think outside the box. All right. Do you have any questions for us?
Did you have any questions?
Would you recommend us like making it taller or like kind of wider?
So, and in the directions initially, Glenn put that it was 2 meters long, right? And only 1.5 meters high. But actually, we don't want to, it does not have to be 2 meters long. It could be the 1.5 meters long and 2 meters high. So 2 meters high is already 6 feet. And that is good. But you have a great way of expanding the roof, which I really like. So you can keep it as your 2 meters long if you want. You don't have to change that. I'm sorry, Julie. What was your question?
Like, would you recommend making like having it expand taller or kind of making it wider or longer?
Well, you're making it taller, right?
Mhm.
So I like the way you're making it taller. I think that's really cool. And you're making it longer too because the two sides are falling down, right? So you're
Yeah.
doing both. I think that's the best combination. You've already come to a great combination. Does that make sense?
Yeah.
Okay. And what? Any more questions?
Um, do you, I mean, I can't find any information on how even approximately big the life support system is. It's really
Oh,
hard to tell.
the eclipse. I know you mentioned that. So I don't know, Glenn, are you able to talk now? The question was how big the eclipse system should be, but I think he's still frozen. It looks like it. Just don't make it very big.
Okay.
Don't worry about it because we actually make eclipse systems that are portable, believe it or not. For countries where they don't have any clean water, there's a portable one that they can use, carry with them to the lake or the river and filter the water that way. So I'm not even sure that is a requirement to to put it in, but I would put it in. Because he does say you need required equipment, 2 beds, a small airlock for samples to come inside, food boxes, and they can just be like a little thermos container. You can make it out of cardboard. Food boxes and water for 7 days, wastewater and solid waste storage for 7 days, a window, a table, and a hatch for attaching to the lunar habitat. And you even have that pathway, the walkway to it. So that's really cool. I like your design. I really do. Keep that up. Keep expanding on, the requirements. Keep checking back on the website because he adds things to it all the time.
Okay. I have one more question.
Sure.
How much water is expected for astronauts to use on the moon?
So water for 7 days for 2 astronauts.
Mhm.
So they're going to drink as much, just research it. How much water do we drink each day on Earth?
Okay.
And that's how many gallons we will have to use for the moon. How's that? Just compare it to Earth, well, which it may or may not be the same, but it's a good way to start.
Okay. And actually, I just thought of this. Do we have to deal with radiation protection at all in this design?
Oh, that's a great question. And I would love for you to deal with radiation protection. Actually, no one has brought that up yet, but your tarp for the top, that should be so you can use the material you have, right? But you could research what material that would provide radiation protection and small meteorites falling onto the camper. And where would you look? Look at the spacesuits. See what kind of you can tell, and this is part of the project. Tell NASA what they should make it out of. You can make it out of any material, but it's good you're thinking about radiation protection. So that's really an important part of it, which no one has mentioned yet, but I think that's vital because we don't want the astronauts exposed when they're out there. So the heat is a problem, the dust is a problem. Make sure no dust gets into it. But the radiation is a problem too. Good question. I think that's Glenn keep texting me. I'm not sure. Is he on? No, I bet you that's Glenn. Any other question?
I think I'm good.
No.
No?
I think
Okay. Keep up the good work and you can ask me questions anytime. Just copy your teacher on that.
awesome.
Okay. And I'm recording it, so I'll send it to Glenn. He says, although I could hear and see you guys, you could not hear anything that I said. Sorry for the poor connection. So I'll tell him to join, even if he can't talk. How's that? You have a wonderful afternoon there. Enjoy the nice weather.
Thank you. You
Thank
too.
you.
Okay.
Have a
Thank
good
you,
day.
whole
Bye.
team there. Bye-bye. Bye-bye.
Bye.
Bye-bye. All right. So next up is Billings. Hello, Billings.
Hi. Hello.
We have the same weather as
I just saw
Olympia,
it.
Washington. So what class are you in right now?
Well, currently behind us is the Intro to Engineering Design class, I believe. They wanted to watch our presentation.
Oh, that's so awesome.
Yeah.
Okay. So hold on. I'm gonna tell Glenn to join. He can't talk, but I'll tell him to join with the I'll call him and I'll tell him he can chat if he has a question or comment. How's that? All right, hold on a second.
Sounds good.
Okay, so we're going to start without him. I'm recording it. He actually is driving right now, but he's going to pull over and try to connect. He was connecting before, but it wasn't working very well. So let's just do it with us, and
Sounds good.
hopefully he'll join. Thank you so much for waiting, guys. All
Yeah,
right,
not an issue.
I'm excited to see what you have done here on your camper.
Right. We're gonna start off by introducing ourselves.
Yep.
So I'm Tommy.
I'm Peyton. And I'm Nick. And then we're the Career Center group, obviously. We're working on our Lunar Camper Lab.
You want your PowerPoint? Ready for PowerPoint?
Yep.
Yep.
Okay, we're gonna share a screen now.
Okay.
Can you see the PowerPoint now, Flo?
Yep. It looks
Okay.
awesome.
So first, we just decided to go over a brief introduction of our constraints and stuff, just so we had a general concept of what we were showing in this presentation. So our camper obviously has to compact to 2 meters by 1.5 meters by 1.5 meters. Obviously, just small, but it also has to have food, water, and all sorts of living conditions for 2 people for 7 days. It has to connect to our lunar module and has to have 2 suit ports for our astronaut spacesuits to connect to. And we also have our implemented, so it's gonna fold up for easy transport to the moon, but it's not gonna compact down. So I think we all know the general constraints of it.
That's good. Actually, some people thought it had to be 2 meters long because that's what it initially said. But Glenn has changed that. It could be 2 meters high, 1.5 meters long, and 1.5 meters depth. But I think you understand that.
Yep.
Right.
Sounds perfect.
So during the brainstorming phase of our project, we agreed upon our camper having solid walls that folded together like a cardboard box would. If it was broken down, you made it. So on the image to the left, you can see the basics of what our idea was at the start. And many things have changed along the way, but the basics of our drawing have actually stayed the same with the current design we have right now.
Once we agreed that we wanted to use solid walls, which was actually an important decision in itself, we thought that if we use soft canvas-like walls, kind of like what's found on a tent camper on Earth, there wouldn't be a lot of room for adding stuff on the walls like our hatch and spacesuits. But anyways, moving on, we first tried making this with 3D printed pieces, and then we kind of tried going away from that just to try being more creative. So we ended up moving toward, we tried cutting plywood pieces using a laser cutter. We thought it would be easier, but it ended up just making things a lot more complicated and not to mention messy because obviously it burnt the wood, which got ash everywhere. And then after that, we decided to go back to 3D printing, and our entire model is 3D printed besides a few small parts. And along the ways, obviously, we've redesigned a lot of things and to solve a lot of issues we found along the way. And basically, what we concluded with is our large walls are walls that fold out to make a room extension. As you can see in the pictures of our engineering journal to the left, you can see how those walls, the inside of the wall folds out to make a room extension. And then you can see that a frame of the wall is left behind that stays up, and that's meant to be a structural support for the roof. And let's see here. I'm sorry.
I like that design, and I really appreciate your engineering books. Look great.
Yeah. Mr. Edison has always taught us to keep a good engineering journal on hand, so that's what we did. And then, as you can see with those walls that fold down, obviously we can't just have that unsealed. Obviously, we're in space, and so obviously it's not in our model currently, but we did find a solution to seal that extended room up, and we're going to use some type of airtight plastic or canvas. And we want to make it to where the astronauts put that on themselves manually after the deployment of the camper using an airtight zipper, which is actually made. We found a company that makes those in Bozeman, and they make an airtight zipper that would work perfect for our idea here.
Oh, wow. So keep in mind that when you demonstrate this, we need you to be able to completely set it up in 2 minutes or less.
Right. Yeah.
And there is, if you have some canvas or things that you need a zipper put into, I know a person here in Billings that does that.
Okay.
Well, that's good
We'd
to
appreciate
know.
that.
Yeah, we'll keep that in mind as we continue on.
So we decided to implement folding walls into our camper because it allows us to save as much room as we possibly can. We have 4 different walls that fold up along with a folding roof. Folding roof is on struts that will extend outward when it's being expanded. So we have the 2 walls that are implemented into the bottom, so they fold on top of each other. And same with the other 2 large side walls; those fold on top of each other as well. So they all have their own specific function. We try to implement as much as we could into each wall. The rear wall is going to have 2 spacesuit ports, so we can put their spacesuits on it, and that's going to be in the rear because it keeps it out of the way of the hitch and keeps it out of the way of if the camper jackknifes with the lunar transport vehicle, then it's not going to damage any spacesuits or anything. The wall to the front, or that one is gonna just have extra storage and stuff on it. We have our interior design with that too, but the side walls, like Tommy was saying, they're gonna fold out for extra room into the camper. The hatch is gonna be located on the top. We decided that so we could save as much room as possible. It'll compact down so it doesn't have to be exact dimensions to something. A ladder will be on the outside of the hatch, so when they do dock it to the lunar module, then it will fold down and allow them to move into the lunar module.
Okay, could you stop right there? Because I'll forget what my comments are if I wait to the end. So go back to that slide. All right. So the 2 kind of like windows are where the spacesuit ports are going to be. Is that correct?
Yes, we have parts in there as right now to demonstrate that.
And then the hatch to get into the habitat on the moon, is that up on the roof there?
That is up on the roof. We have a part on there right now. In that photo, we don't have the part, but we do have the hinge and everything in there.
How is it going to? How is this camper going to hook up to the habitat on the moon if they go in and out of that habitat from this route?
We are gonna plan on having the lunar module build something so it connects to there, or we took inspiration from the IDSS, it's the International Docking System standard that they use on the space station. They move it around to connect to a hatch properly.
Yeah, I'm not sure we're going to be able to do that. Is there a way you can move that to one of the sides?
Oh yeah, I think we could do that.
Yeah. And why did you want a ladder?
So they could get up and into the lunar module easier.
Yeah. So I would put it in the side where they don't need a ladder, like in the pink thing that comes out. Maybe you could have the hatch when it's folded up, you could have the hatch there. Like one side could be folded up and down. Or in the back where the hitch is going to be, right?
Yeah.
Okay. Yeah. Make it as easy as possible to get in and out of that camper.
Well, the thing is here, our thinking here was the main way the astronauts are going to get in and out of this camper is via the 2 spacesuits, spaceports that you see there for their spacesuits, obviously. And what we were thinking with this hatch is the only reason they're going to need this hatch is to get in and out of the camper once before the mission, once after the mission, and obviously after the mission's over, they're going to need to clean out stuff and whatnot. So this hatch isn't going to be used as much as the spacesuits was our thinking here, which is why we went with the roof, because we thought it was less important than the spacesuit ports themselves.
So you're absolutely right. The camper's going to be going to around on the moon, and they're going to go in and out of their spacesuits. But they're also going to go in and out of the lunar habitat on the moon. And so instead of having to get into their spacesuits and walk to the habitat, which they could do, if you had a hatch that linked up to the lunar habitat, that would save them from having to go out, outside in their spacesuits to get to the main part of the lunar habitat on the moon. Does that make sense? So they're not going to just use it once. They're going to use it every time that they link up with the lunar habitat station on the moon. This is just if they want to go on a excursion, right?
Yeah.
But they even to the camper. So if they were riding around in the lunar vehicle, they would need to go into this camper from the lunar vehicle, right?
Yeah.
So we need a way that they could go from one protective habitat place, either the habitat or the camper, into this place without putting on their spacesuits. Does that make sense?
Yep.
So if that was moved so they could easily go in and out, that would be a better design for that. Keep going. Sorry to ask so many questions.
That's no problem.
Okay, sure. And then moving on here, we're just talking about a few of our things here. We decided to implement our suit ports into the back of the camper to decrease the amount of clutter in the front of it, because you'll see soon here in the front of our camper is where we decided to put our hitch. And basically our thought process there was if our suit ports are on the same side as the hitch, then the astronauts are going to have to walk on the hitch all the time, and it's just going to be a big mess. It was kind of a common sense kind of thing just to put it away on the other side. So that's what we did there. And then with our hatch, obviously, our thinking here was putting the hatch on the top. We just keep it out of the way of other things. And we were under the assumption that because we went with a hitch style instead of a pickup camper style, the astronauts would already be in their spacesuits for moving this thing around, because the photos on the HUNCH website for this shows that the vehicles used to pull this camper around isn't an enclosed vehicle, and it shows that the astronauts are already in their suits controlling this vehicle. That's kind of where we got that idea there.
So now I totally understand why you did that. But in actuality, the lunar vehicle this is going to be attached to the lunar vehicle, and that lunar vehicle hasn't even been designed yet. So there's different designs. Some of them are with the astronauts already in their suits, and some of them aren't with the astronauts in their suits. So in actuality, if you want to then specify that, hey, we're going to use the design where the astronauts are already in their suits, right? Because then it's not changing. Then they don't have to go in and out and put their spacesuit on because it's already in their suits. So,
right.
Yeah. So I understand what you're thinking then. I was thinking that they're not already in their suits. So,
right. But if they're already in their suits, then there's no need for them to enter through the hatch, was our thought.
Right. Yeah, absolutely. So when you do present it, just show a picture of how the lunar vehicle is going to be designed. This is the way you are using the vehicle that has the astronauts already in their suits. So
Right.
thank you for that explanation.
Right. Yeah. Sorry, we made that confusing. Moving on here, then we have our sample airlock as well, and in further pictures you'll see where we put that. But basically, we just put the airlock in an easy place that you can get access to easily inside or outside the camper. Obviously, if they're walking around in their spacesuits outside of the camper collecting their samples, we just want to make it as easy as possible, and that's exactly what we did here. That's kind of all I need to say about that.
Mm-hmm.
And then next, obviously, a very important part of our camper is where is it going to get its power? And we thought it was kind of a no-brainer here to go for solar power with because our camper is only going to be out during a lunar day, so sunlight's going to be readily available. There's no need to overcomplicate this system here. We want to use 2 large solar panels on the roof, creating a 300-watt system. Obviously, in direct sunlight, this system should be more than sufficient for charging our batteries. And a very important piece of the system is inside our camper, we want a solar panel monitoring system. These little systems come with solar panel kits for regular campers found on Earth here. And basically, they're kind of important because they regulate voltage coming off the panels, they regulate amperage coming off the panels, they regulate how full the batteries are, and they also prevent overcharging, which is a serious issue with solar panels because obviously solar panels don't stop, right? You can't just unplug them and they stop. Even when they're disconnected from the battery, the solar panels are still turning some sunlight energy into electricity, and so this monitor stops overcharge.
Wow.
For our batteries, we want to go with some dry cell batteries because wet cell batteries gas off when they're charged. They emit toxic gas. I believe it's carbon monoxide, but I could be wrong about that. And obviously, that's going to kill our astronauts within a few days. And on normal campers, they use wet cell batteries, and they just have a simple vent venting these toxic gases outside. But clearly, we can't do that because there's no air outside. That's going to release all the pressure from inside our camper if we have any style of vent like that. So we thought a dry cell battery was a no-brainer as well because they don't emit toxic gases, and they can hold a charge better than a wet cell battery.
Good.
So our airtight seals were planned on going on the sides of the walls because when we fold up the walls, there's still a corner that isn't there. So by taking a small, say, rectangular piece and putting it in there, you can connect it to the bottom for electricity directly to the camper. But as you can see in the drawing, to the top right, it's supposed to go into the camper wall. So it's there's gonna be hooks similar to carabiners, minus the fact that it's not gonna be on the side of the carabiner. It's gonna go on the top of it or on the front of it. So it'll push into that hook anchor, and it won't be able to detach since you're not gonna want to collapse the camper again, since you're gonna lose all your oxygen. It's gonna, and then it's gonna pull it down and press it up against a silicone seal on the side of the wall using a linear actuator in the bottom of the photo, just making a proper seal on the wall.
And that's real important for airtight seals. A nice design.
Thank you.
So for our camper wheels, like it pulling on the moon, we decided to kind of copy the design of a car control arm for the suspension. So we decided to use a spring, which can actually be removed. So when the camper is like out and it's not moving, it can stay in position a lot easier because those wheels actually fold up into that hole that you can see in the picture. And so when you're driving, the spring will act as suspension because obviously you're not on flat ground. And for that like real design, we thought airbag would be much more efficient because it would actually stay in there, so you don't have to actually remove the spring. The airbag will just like deflate and the wheel fold up.
Huh.
And then here's our floor plan of the actual inside of the camper. So you'll just be like standing on that white part and on the red. And you just like pull everything up that you need to use on that day. So like on the top left, you have a big storage compartment that holds all the beds or anything you need while you're traveling. And then you have the battery storage, which you can pull up or you stay in there because they're batteries. And then you have the lab, which pulls up and has storage compartments in it. And then we have our toilet and our fresh and wastewater tank. And then we have our life support system in the bottom left. And then you can also see our airlock.
So that's all receded into the bottom. And when you need it, you just pull up the part you want. Is that right?
Correct. Yes.
That's clever.
Well, with our lab, we kind of thought, obviously you can push it back down if you want, but we were thinking for things that they'd be using every day, like the lab or the toilet, we can use some type of system to hold those up for them for long periods of time. We haven't exactly decided or agreed upon what system that will be. We've kind of thought of a couple things here, such as using something simple like hydraulic struts, or Nick's idea for those linear actuators would also work here. But yeah,
Where's the beds?
So we're going to use inflatable mattresses that, when deflated, they're going to be stored in that big general storage compartment. And obviously, when they need the beds, they can just pull them out, inflate them, and then the bedrooms themselves, we decided would be located in those pink slide-out rooms that we showcased earlier.
Yeah, so it might be not a good idea to inflate and deflate anything up there.
We also had another idea behind it, using a cot with two simple bars that can hold up, like, say, any type of cloth between them. So
right.
it's still
it doesn't necessarily have to be an inflatable mattress. Just
yeah.
So it just
some-
to look back.
Can we actually show you our model now?
Yes, go for it.
So we have a lot of moving parts. Most like 99% of them are 3D printed. So basically, to start off here, we have our roof with our hatch on top, like we talked about before. And then other way. And then, as you can see here, our roof folds up using these mechanical arms, right? And temporarily, they're not super structural supportive, but that's not really their purpose. It's to just kind of hold it up there for a second. And then, as you can see here, each of our walls. Some fits are a little tight. They're not exactly perfect. We're still working on getting these dimensions perfect here. But as you can see, each of these walls are able to fold up.
Yeah, but I like that design. I like that.
Right? We figured it would be the easiest way to go here. So each wall folds up like so. So now we have 4 walls. You can see here. So as you can see, we have our full 4 walls now, and then
our support pieces are on this back.
Awesome. Yeah.
Swapped around.
Sorry, we gotta move on. Everyone got you on this. So as you can see, we have our 4 walls, and then our room extension walls fold out as well. And that's where we wanted to do some type of plastic or super flexible material that folds with the wall to make that seal there. And then obviously we have our hatch on the roof, which also opens from the inside, very important. So we have a tight seal there when it's closed. And then we have a big window in front there, soup ports on our back. And then to get a detailed view of the inside floor pan, we can just simply take this off, and then you can
wow. That is really cool.
And our sample airlock is going to be on the side here for easy access when the astronauts are outside of their mission lab.
And then, as you can see here, with our inside pieces here, you can see they come up here, and then we have our lab. It's got a sink and everything they would need there. All the pieces are kind of socket, like a puzzle, almost like that. And then you can see here, just real quick, with our axles here, you can see how without the spring, they can fold up and hide inside. And that allows our camper to maximize the dimensions we're limited to during transportation. And then obviously once in use, we can fold those back down and has tight suspension.
Wow, you've done a lot of work on this. That looks super. That looks really nicely done, guys. Do you have any questions for me?
I had one question that kind of came to mind, right? So we're designing our camper to where the dimensions are limited on this. Someone can grab that stuff. the dimensions are limited on this because you guys are saying how we don't have a lot of room on the rocket getting it there, right?
Right.
And so that's why our dimensions are limited. Now, my question was, why aren't we just sending the materials to build this camper to the moon and then building it there on the moon and avoiding all of this complex moving parts? Because this whole entire project is based upon the fact that there's already a permanent lunar base on the moon at this point. So why can't they just build it there? Is my question.
Well, that's a great question. And maybe we will. I don't know, because we're actually looking for aluminum up there. So if we have some aluminum, why not? And we're going to have 3D printers. Why not 3D print most of those parts that you have there? But for right now, we're just designing everything that we would need to live up there and to send up there in a very small, compact space. 2 meters by 1.5 by 1.5 is a small area to send a camper up, needless to say. But we're really thinking of doing that for now. But eventually, I think we would. Just when you get up there, you make sure we build it up there. How's that?
All right.
That's a good question, though.
I did have one more question too, so I'm going to take this off so I can illustrate this question. So you can see here we've incorporated a standard hitch style on the front of our camper here, like almost every single camper found here on Earth. And obviously, this is used as you're going to be using a tongue to attach it to. We are allowed to do that, correct? This theoretical vehicle that's pulling this camper, it will have a tongue hitch like that.
Well, so it hasn't been designed yet, needless to say, but if that's what you need, that's the way we would design, the hitch for it to be. So that hitch needs to fold up or something to be within that 2 meter length, right?
Yes,
Right.
it would.
Once it's deployed, it looks like that, which is fine because we got plenty of room once it's deployed. It's just sending it up.
And in our design here, this hitch is also it's also able to fold up and press against this wall here. We're just it's kind of stuck at the moment, and we're not able to get it folded up.
That's okay.
Will be in our design, and it was. It's just currently stuck, and we can't really showcase that. But that's how it's supposed to work.
But that was smart to put the spacesuits port on the other side because we don't want
to. You're going to be flipping all over it. Exactly.
Yeah. No.
Another. Oh, I'm sorry. Just a quick comment. Another reason why we have everything in the floor here and nothing externally is because, like our freshwater tank and our wastewater tank, they need to be heated. Obviously, on the moon, it's super cold, and if we have any water tanks outside, the water's going to freeze and crack and break. That's why everything is inside and in a heated, pressurized area.
Yeah, I like that design, putting everything down low and getting it if you need it. That's pretty cool. Nice job. Thank you so much. And thank you for missing your class. Also, I know this isn't your class time. I'll come visit you guys next week. I won't be so busy with preliminary design reviews. So thank you so much. And have a wonderful afternoon. Thank you for waiting all that time too. I appreciate it. Okay. I appreciate you guys. Thank you. Thank you, Mr. Anderson. Bye-bye.
Yeah, thank you.
You can stay on because next
we'll stay on and watch the others here.
Yeah. So next is Frontier again. I hope they can join us. Hi, Frontier.
Hello.
So is your school almost over? How many minutes do we have?
Our school ended about an hour and 15 minutes ago. We've just been hanging out after school.
Oh, thank you for waiting after school. Appreciate that. All right, so we're ready to hear what you have for your lunar camper. Introduce yourselves first. You can share your screen if you want.
just do entire screen.
Oh yeah, because you're back east.
Yeah. There we go.
I'm Andrew.
I'm Maddie.
And I'm Camden. And we're doing like the Lunar project, obviously. We have a couple prototypes here, and then we're sharing our screen so we can show all these different things and like all of our different ideas.
Okay.
So, start. There you go.
These were some of the products that already exist that we used as either inspiration or we adapted to add to our project. The foldable bowl that's at the bottom is something that we used heavily that we thought could be a really good thing to include in the project.
And then we have like for the beds and everything on the inside, we have all these 2D walls, and they would all be very like flat. And then everything, all of like the different like furniture and like objects inside the camper, they would fold down like the bed is folding up in that one photo on the bottom right, or kind of like the doors are like the sliding foldable doors.
You know, I like that picture of the bed folding back up into the wall, because one team today brought up radiation protection, and I said no one has thought about that, but you know, that bed folding up into a wall could be a great way to have radiation protection, more than, you know, just a thin wall between astronauts and the radiation on the moon.
Yeah.
I like your folding containers too. That would use up such less space, right?
Mm-hmm.
Yeah.
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 So these are our prototypes that we started with cardboard, just to get an idea and feel of what we're doing. So can we get our camera?
Yeah. Yeah.
Okay, yeah. So we'll show you after. But we have the cardboard prototype with the pictures where everything we can like handily move it, but just to kind of like show that how like the beds are gonna fold down and like the table's gonna fold down, like we have the windows and everything else will fold down as the walls are like moving out.
Mm-hmm.
So there'd be like a series of like 4 walls on the inside. And it would start with 4 sides folding open to make like extend the actual size of the camper. And then you would grab onto the wall in the inside and you would pull on it and pull it out towards you on the outside of the camper. And it would drag along with it all of the other walls, but they would get stopped one by one by like little pieces on the side of the wall. And it like every layer would have different objects on it. Like the last layer there has the beds, and then the layer in front of it has like a ladder and like cabinets and everything. And each layer would have different objects on it.
Mm-hmm.
You can go use the plastic one.
This is the one that we're currently modifying. There's the base, so it shows that we would actually be pulling these walls from both sides, and not only one. On the right-hand side, that is the design for the walls. The top is what we started with. We're going to end up going with something closer to the bottom. The things that are popping out of the wall is what's going to stop the sliding walls in the place that they need to be.
Yeah. What else? On one side of the camper, it would have like the beds, and that would be like the very end of it, so they wouldn't take up so much space, and they could be on their own in the end. And then the other end of it would have like a blank open wall, and that would have a hatch that would be able to connect to either like the habitat or like an outdoor, anything like that. So it has use of both ends of it would have that.
For the original prototype that we did, we used cardboard and tape. The one that we're currently working on, we're starting with 3D printing. And we want to try to include something close to like silicone or something along those lines, so that we don't have to use hinges, because we found that the hinges leave empty space, which will make it harder to have an airtight seal in the future.
And for the airtight seal on the walls that we would have folding out, they're not like quite connected or touching each other. So to make them connected, we were thinking when we pull on the wall, that would pull all like the interior walls out. It would also like put some like kind of like a caulk on the walls and the corners, so it would make like an airtight seal or like some kind of material, like a plastic or something, that would seal like the corners shut, so there wouldn't be any air there. And any of our permanent objects that wouldn't be able to like fold up into like a flat wall that we would have being pulled out, they would be in the section in the center that doesn't have any, like, it doesn't move at all. These suits that you would, like the ports, I guess they're called.
Mhm.
Oh yeah, yeah, that's good. We can show the
On that one, it's easy to see.
Yeah, hold up your model.
yeah. So we have, this is one of them. So the hinge leaves like this open space here, this way. So we were gonna do, like, there'd be a ceiling piece as well here, and that would fold up. But then
Okay.
because there's like a little bit of space here in between them, that's where we would put the caulk. And then on this space right here, this is the part that doesn't move, and it has all the pieces inside of it. That's where we would put, like, the battery would be inside here, and maybe like the suits would be on the wall here, and the ports and everything, because those don't move at all.
Okay, so it's 2 meters high, which is good, and then 1.5 and 1.5. So hold that up again, please. And so what are you going to do instead of the hinges? Because the hinges have open spaces on the.
We were thinking doing something more like the tape, but with silicone. So it would like kind of bend, and it would just have, it would be like a bendy plastic.
Yeah,
I don't know
yeah.
exactly how to explain it. Yeah.
Yeah, kind of like the silicon bowl that collapsed. Just,
Yes, exactly.
just there. Good. Because one of the major problems is to prevent that air from leaking from that camper, right? All right. So good job. I like the way it's designed. Do you have any questions for me?
Okay, yeah.
Okay, so Nancy Hall is your mentor there. So if you have questions, send it to her anytime. But you need to copy your teacher, and she's a really good mentor. She's a microgravity fluid engineer, so she really knows her space stuff.
So we do have another prototype, the one out of cardboard, which I
Okay.
think really resembles more of kind of like what we're going for.
Okay,
So-
yeah, you had the interior done
Yeah.
nicely.
So it will all kind of be pushed up against, and then the walls fold in also. So this would also fold in like so, like this. And
Okay,
this would fold up. So that it'd be something kind of like this, to where it's like kind of like smushed up.
I
So
like
easy
that.
transportation. Then it
Yeah.
folds out, and then everything will come out, and then past like the stopper right here. It goes and it's stop way out here, and then turn. Our
And you
bed
got
would fold out right here, so the
I
bed
know.
can fold out and fold back in and such.
Good
And then this
protection.
same wall, yeah. And then this
Yeah.
same wall would stop at that same point, and then it would create a table for them to eat and do etc. at, a ladder for them to get to the top bunk, or any other things, and also create a window right over here.
That's a cool design.
Also, really fold it up if we really wanted to fold it back up.
Yeah, I like that design. Now, the one thing, and Glenn, actually, I'm going to read what he wrote me, because a lot of students are using that sliding thing. So this is what he wrote about sliding, all right? Because he couldn't talk last time he was on. Although sliding fixtures add space to a camper when you slide, like you were sliding that out on the ground, they do not have to seal on the ground. Teams need to think about expansion that does not have sliding mechanisms that are not sealed all of the time. Does that make sense to you?
Yeah. Yes.
Yeah.
Teams need to think about expansions that does not have sliding mechanisms.
So try not to make everything sliding, you're kind of saying?
Yeah, he goes on to say accordion folds are better seals. He's worried about the sliding mechanisms not being sealed. So he says accordion folds are better seals. Expanding tubular structures are a good idea inflatable structures have a lot of promise. Each of these has joints that stay sealed from the beginning. So inflatable or tubular have seals that stay sealed from the beginning all the way to the end of the deployment process. He's really worried about those spaces in between with the air leaking out. So take concern with that, okay? And make sure, like I like your seal of silicon instead of hinges. That takes care of that problem, right? It's all one piece. There's no air getting out if it's completely sealed off. So, and I like your cardboard model. I like how the interior moves about. That's very original, creative. I appreciate that. Okay. Any other question?
I think we're good.
All right. Well, thank you so much. And thank you for staying after school. I really appreciate that. Have a wonderful afternoon.
You too.
You too.
All right. Bye. Bye-bye. And you can stay on and listen to, I think it's Gallatin High School. We're ready for you, Gallatin.
All right. So
Awesome.
we're the Gallatin High School Lunar Camper Team. I'm Reed.
I'm Jackson.
I'm Avery. We'll pull up our slideshow. There, yeah.
So Dylan isn't there?
Oh, sorry. 1 second.
Yeah, that's
Technical
okay.
difficulty.
I saw it for a minute.
There we go.
All right. Can you see our screen now?
Yes. And it's loading.
Okay, cool.
Yeah.
And to answer your question, no, our other teammate could not be here today.
Okay.
Our other teammates flying to Hawaii.
That's the second teammate that's gone to Hawaii this week.
Really?
Oh, really?
I think from Wyoming Indian High School. They went. One of the students was going to Hawaii.
Oh, interesting.
All right. So our interior is going to have 2 hammocks to sleep in. So we have a pocket design for our camper. So the whole inside is going to be coated with a cloth with little pockets sewn into it.
Awesome.
And then you can hang, like you put a metal rod into it and you can hang stuff off of it. So that's how the hammocks are going to hang. And then you can just fold them up and put them in a cupboard or something.
And when they're not in use, they're going to be clipped to the wall. So when they're not in use, they don't take up any space. So they just, they're part of the wall.
Right. And then we have our airlock, food and water, and then wastewater and solid waste storage is going to be outside, actually, mounted to a wall or under. And then a window, the table, the toilet, and then a microwave for making food.
You know, we don't have a microwave on the ISS.
Really?
Oh, really?
Yep. They have only warm and cold water.
Interesting.
So there's a few different types of wheels that have been, tested to be on the moon. The rubber wheels inflated with nitrogen, the idea is good because you can store them and inflate them when you get there, but the rubber degrades really quickly and they don't tend to hold pressure. Those are wheels that are used on cars on Earth. And then the hoop spring wheels are pretty similar to wire mesh. But wire mesh is definitely the best option. They've been tested to be the most comfortable. They keep good traction. So if there's craters, the rover or the like camper won't get stuck as easily. It can get out, and then it'll have a stiff inner frame to prevent over deflection, keep almost like a smooth ride. Yeah.
Those are all our ideas for the wheels for the camper.
And this is more for us, but this is the exterior description from the PDF. We're going to use solar panels for our power system, and we're going to have batteries, deep cycle batteries to store it. And we're going to have our internal pressure at 10.2 psi. And then just got to skim through really quick. We're going to have some equipment bins mounted to the outside with that same kind of pocket idea for tools for when you're doing EVAs. Yeah, I think that's it.
Oh, and this is just the material that'll be made for the, this is like the cloth material. This is what it is. That's going to expand out. It works to be very strong, almost like steel. So it'll be resistant against ripping or anything that tries to damage it.
I've never heard of Vectron.
Really?
Yeah. Do we use it in space at all now?
I can go, I mean, I haven't read into exactly what's been used, but I know that it's been tested with some lunar rovers and spaceships.
Oh, awesome.
I'm not sure if there's any active ones that use it, but I know it's at least been tested with some.
Yeah. So
that,
you don't have to use that material. You can just use anything that kind of feels like it, is flexible like it, something that's handy. It probably costs a lot of money, some new material.
These are just like, if NASA were to use our model, this is like
what you want them to use. Yeah, that's awesome.
Yeah.
That's part of the project, to tell NASA what they should build their camper out of.
Sure.
Right?
Yeah. So then aluminum is going to be used for all of the like solid walls and the floor, and then our hitch. And then we could use this TPU coated nylon for the outer material. This is just another option. It's just like plastic covered fabric. Polymer composite would also be useful. And then beta cloth is what's used in NASA's spacesuits right now. That's what they're made out of. So that would also work really well for insulation because it's can repel radiation really well.
There's like two main types of materials for windows that are used in space. There's acrylic plastic and polycarbonate plastic. Those are going to be there. Well, there's that, and then there's aluminum silicate glass, but the glass has a tendency to crack if it's hit with any sort of material from the moon. And the plastic is more, it's less susceptible to like breaking, so it should work better.
So I love that you're looking into the materials, because that's an important part of the project, to tell NASA what products they should use. And actually, what you were talking about is frangible. So that silicate glass is frangible. It breaks into a bunch of little parts, right?
Right.
We usually use Lexan, which isn't frangible. It's non-frangible. It doesn't break into a million little parts if it's hit. That's kind of the plastic that's used. The Lexan is used on motorcycles, where there's a shield there. So, and we use it in space all the time too, on the ISS and other places. So.
Okay. And then we have our wire mesh wheels.
Yep.
And the materials we'd be using is canvas for the walls that are expanding and insulation, and then wire just to hold them out, kind of give them some stability, cardboard or 3D printed materials, and then window just made of like a clear plastic sheet.
Mhm.
and then foam wheels.
Good. And those are all similar materials that NASA would be using, the same feel to it, right?
Yeah, we're gonna switch over to our
Prototype.
really quick.
Sure.
So
Yeah, so this is our prototype model. It would be kind of just like a box that when it comes out of there we go, the rocket, the astronauts would extend it out with canvas, and it would, like, the pressure would push it out and expand it. So then it's pressurized, and then there's wheels, and then there would be a hitch on this side for the astronauts to tow it with a lunar rover. This is like the canvas. This is what would be like the beta cloth and the Vectran. Then as for like the airlocks,
and then for this expanding part, it would work kind of like the airlocks on the ISS, where they have metal tube rings inside of it to support it. So they all, when it's compressed, they all stack up in one spot, and then as you expand it, they all pull out and spread out.
Good design there to hold it in place. So where is the spacesuit ports going to be?
show that. So on the back, this is front, designated spot for the airlock ports, the suit ports, and then we'd also have a sample port like right here. And that could be however big NASA needed it to be. Same with the suit ports as well.
And where's the hitch for is that on the same side as the spaceport?
Yes, the hitch would also be down here.
Okay.
Yeah. And then we also have a designated spot for windows on these walls. NASA could put those anywhere they wanted, really, just based on how much window space, I guess, they want for the astronauts. And then we also have the hub airlock that would attach to the permanent lunar base. That would you just back it up to the airlock. Yeah.
Yep.
And then it would attach.
Awesome.
And then all our go ahead.
I like how simple it was to expand it.
Yeah,
and good sewing too.
Thank you.
Yeah, and the thing was that we were thinking was NASA could sew the fabric or whatever fabric they use however they want, like in a specific way, probably in like a accordion style type way, so that it folds or unfolds like without any problems, and so it holds pressure. And also our corners in our final prototype are going to be rounded, because like rounded corners will hold pressure better, and we don't want a pressure burst.
I love rounded corners and rounded edges. That's, the astronauts, they're going to be in their spacesuits outside of that, right? And we don't want them to hit a sharp corner or edge and mess up their spacesuit. That's for sure. Here, Nancy Hall has just joined us. Nancy, welcome.
Hi, hello. Yep.
So this is actually the last one, Nancy. It's Gallatin High School in Bozeman, Montana.
Okay. Hi, guys. Yeah,
hello.
I'm Nancy Hall. I'm over in Cleveland, Ohio. I work at the NASA Glenn Research Center as a researcher. So I do research in fluid physics, looking at the behavior of liquids in a microgravity environment.
Yeah, so actually, Nancy, I have a question for you. They were putting the waste outside. Is this right, guys? You were putting the waste outside of the camper.
Yes, we were planning on mounting tanks to like an exterior wall.
Is that a good idea or not?
Oh yeah, if you're gonna put it outside, are you gonna? When you say you're gonna put it outside, are you gonna have a mechanism for it just to store it, or is it gonna be packed? How?
It's just going to be stored in tanks, just mounted to like the walls or under the floor.
Like, is it gonna
Okay, because so there's going to be piping that'll take. Is it the solid waste or just the regular waste from?
It's going to be both. They're
Okay.
both going to be stored separately, like
Okay.
a gray water and a black water
All
tank.
right. The only thing with the solid waste is remember solid waste in general contains bacteria and things like that. So a lot of times they'll have notes and stuff. So you can store it outside, but you probably want to find some way of enclosing it. And you don't have to design it, but you want to mention that with the solid waste, you want to find a method of enclosing it and storing it in a place. You want to seal it because over time it will smell. So you want to have it sealed and then put in a container and something like that. Have you guys seen the movie The Martian?
I have. I've read
the book.
Okay. Well, in the movie, remember when he's going and then he thinks about it. Notice how they have it sealed and after it's sealed, they put it outside in a container. Yeah. So as long as that's done, you can just reference it that way.
Okay.
Yeah.
Perfect.
Yeah, that would be
good question.
Yeah.
Right,
Show Nancy your model.
I'd like to see.
Yeah, so this is our model. It uses like a canvas, and it would
oh, nice.
After like arriving on the moon, it would extend out like this and pressurize. The corners would be rounded, so it doesn't cause like a pressure leakage, or it doesn't burst. And then there would be metal tubing or things to help it extend out.
Okay. Yeah, that's neat. When I first saw it, I thought it was an inflatable, but yeah, the canvas is nice. Yep, that's a good material, and it gives you that flexibility. Nice.
So they mentioned Vectran, VECTRAN, as the material. Have you ever heard of that, Nancy?
Nope, I haven't. Is it an artificial fiber material, or is?
Let me get some more information about it for you really quick.
Okay.
On our slideshow.
Yeah, I haven't heard about it. I'm wondering if it's because there's lots of, because if you think about like spandex, all those, they're always making materials of different things in, from different processes. So that's what it sounds like it is.
And the other thing they mentioned was a microwave. Are we going to have a microwave on the moon?
Not necessarily. Yeah, I mean, because right now, even on the station, we don't have a microwave.
I told them that.
The heat and the radiation, well, not really radiation, they use a convection oven. So do some research to find out what's required. With the Vectran, since it's going to be on the lunar surface, have you done research to make sure it can handle the vacuum and everything? You want to look at that.
It was more going to be for our interior design.
The interior, okay, that's
just like
that's
as because it's really strong, but also it off gases. It doesn't absorb gas; it actually releases it, so it's not airtight. So we have to use it as like an interior wall, and then we have airtight material.
Okay, so you want to be careful when I hear someone say it off gases. That means it releases chemicals. So normally with NASA, we actually do off-gas testing where we heat something to make sure. So you've probably seen it where you open a box or you open something and there's like a smell to it, and that's called off-gassing. You do not want it to off-gas inside the compartment. So you want to double check and see what they mean when it says off-gassing.
Okay.
Right, because this is completely enclosed. We don't want to lose any air.
Yeah,
so
and we don't want that.
Yeah, we don't want that smell.
Yeah, so that smell would stay. Yeah, that's exactly. That smell would not leave if it's off gassing.
We have the same problem on the ISS. No off gassing, and it's like the smell of a new car, or new carpets or something like that. Materials don't off gas. All right. So, do you have any questions for us?
We do. We have a little more on our slideshow.
Okay, yeah, go back.
Back over there.
Yep.
Can you guys see it now?
Yep.
Yep.
Okay.
All right. So here is just a couple of other methods we looked into a little bit. It's like a radioisotope power system.
Yeah.
They don't really produce enough power for what we were doing.
For such a short time period.
right? It's more of a low producing long term
Yes.
system.
Yeah. And if you think about it, that's why we use it for our rovers on like
Right.
Mars and stuff like that, because they work great in that. Yeah. So good
Um,
point.
And then we did a little looking into a mesh style wall folding. So like a wire mesh wall design with a canvas stretched over it to fold. And then we decided to go with a different system. And then I'll let you talk about the last
The oxygen assembly and the urine assembly, those would be great, but they're very large and we don't have the space for that. And they might not even be 100% necessary since we're only up there for a week. So it would save a little bit of hassle of storing water. But since they recover 85-98% of water content in sweat and urine, but we're unable to use those.
Yeah. So think about it again when you write oxygen generation assembly. Think about where you get it from, and you're correct. So the system that's on station that we use is not there. But one thing you may want to think of, and they've mentioned, is think about like the Winnebagos, people who have campers. They have some sort of system that processes it. So see if it's possible to like miniaturize it. Or
Okay.
you mentioned a different method, but yeah, just don't discount it. See if there's a way you could use that. Okay.
Okay. Thank you. And then here's a drawing of that same design that we modeled. And then we linked in a couple of papers. This is about the airlocks on the space station. This is where we got our kind of expanding design from, is those airlocks that collapse the primary and secondary on the ISS. And then this is the life support paper, also for the ISS, about their oxygen generation and water reclamation
That's where
systems.
we got a lot of our research.
And then, what kind of testing should we be doing, like with our models?
That's one of the questions we had.
Yeah, that's a great question. And one thing that I know that you have to test is, and yours will be so easy, but what you have 2 minutes or less to set up your model. Okay.
Okay.
So that's one test that you can do it, and you can set up your model right now in 2 seconds, right?
Right.
So that's really good. It's more not testing of this, but we would like, even if you could, make 2 different models. One that you can expand, right, real quickly, and then the other so we can see where you're putting everything that you're putting and label it and tell us what it is. So you only have, well, you're going to have a poster board. What is that kind of, what's that called?
The trifold.
Trifold. Yeah. So make sure that your models fit inside of that, right?
Yeah.
Which will work really well. Let me just see if he has anything.
The other thing I was looking that up is make sure you go back to the project guidelines. Look at the last page. The last page is what we expect you to do at CDR, and that's how we will be, evaluating all the students. So, and it's highlighted in green. So you want to go back to that.
And I was just reading it. So it says, make sure you have a skill model for assembly, and a skill person. It wants a person too, to demonstrate with. Did the team completely assemble in 2 minutes or less? Does the team have information on assembly and materials that support the need for the camper to be airtight? That's an important qualification. Does the team have design drawings with appropriate dimensions so that we can, so it could be replicatable? Are the recommended materials of the camper appropriate? And you did a good job on that. What you're going to use and what NASA should use. Is the design and construction easily reproducible? And that's important. too.
Okay.
Does it make sense?
Yes. And then how much space does like a person need? I guess we don't really know this. Like on the moon, how much space does one person need to be comfortable?
Like based on NASA's experience with the ISS, what would be reasonable?
I was going to say that's a tough question. The thing with the moon and with this camper, and you want to think about is they're not going to be, it's an enclosed environment, but they won't be there for long. So it's kind of hard to explain. I mean, there's probably people that's done research that says, for someone to be reasonably comfortable, this is how much space they need. I don't know offhand, but like I said, the key thing is it's not like they're going to be living in that small area for a long period of time.
Right. Yeah. I would ask a camper company that question, how much space does the company think that to be comfortable in one of their campers a person needs?
Okay.
That would be interesting. Yeah.
And then would the wire mesh wheels be enough to support the weight of a camper?
With the which one? I missed that.
So they were designing wire mesh wheels for their camper in front and in the back. Well, don't forget on the moon it's 1/6 the weight.
Yeah.
Right.
And NASA has a lot of research with the wheel. They've done do some search on NASA and wire mesh wheels. I mean, one of the things with that is they do flex. So I think that's one of the things that's good for them. I don't think you're going to have anything there that's excessively heavy, but that may be some of the research you may find, and it may help you out with that.
Yeah, we can't bring much heavy stuff up because $1.2 million a kilogram to bring something up to the moon. So, yeah, I would say you're good with that.
Mm-hmm.
And the last question, is there anything we can improve about the shape? And you already mentioned the corners.
Yes.
Yeah.
That's the biggest thing. Yep.
And make sure it's airtight.
Yes.
Yeah.
Those are the biggest things.
Yep. All right,
Any other question?
I don't think so.
That's it.
Okay, you can always send me questions. Right, just copy your teacher.
Yep.
All right.
All right. Yep. You have a wonderful afternoon. Thank you. Nancy.
You can stop recording, Flo. I was gonna let you know.
Well, I'm gonna see if Billings is still on. Billings, are you still there?
Okay.
I would love your input on Billings.
Okay.
Let's see if they're still.
I just sent a message asking if we could do that. So.
Oh, you did? Yeah, good.
Yeah.
Okay. So do you have a little more time, Nancy, so they can present to you? Because they just presented to me. All right, guys, you're on, because they have a very unique design that I really would like you to see.
You can hold it up there.
Yeah, you don't need your PowerPoint. You just need to bring that.
So basically, we have an entirely 3D printed piece here. And
nice.
We have our roof raises like so. It has a mechanical arm at each corner here, which holds up our roof. It's kind of hard to tell what it is though. And then our walls are folded on the inside, and each of them individually raises on the inside like so. I stuck on. Okay. So we have 4 walls, obviously, and each wall raises after the roof is raised, as you can see. It's a little tight because we kind of made a small model.
It still looks good.
Here.
Yeah. Okay. What's nice about that, you just saw something broke, but all of our hinges are snap pieces. And basically we're able to just snap everything together. That's how our hinges
that's
work.
Cool.
So basically you see that all 4 walls.
You have to pull those down to get it up.
All 4 walls fold up after the roof is raised, and The walls also serve as structural support for the roof as well.
Nice.
We have these two side rooms that fold out here to make an extension of a room.
Okay.
Airtight zipper you got.
All right, and then with our model, that piece just simply comes off there. Then you can see our floor plan on the inside.
Yeah.
There.
Oh, nice. Yep. That looks very good.
And basically, our design on the inside here, basically everything the astronauts need is kind of built into the floor. Like right in the middle here, we have this lab, and basically they raise it up when they need it, and now you have a lab in the center there for them to work on. We have sinks, we have storage all over the sides and whatnot. And then we have our demonstration, like we have a freshwater tank here, a black water tank there. In the front here, we have this huge storage compartment for clothes, beds, food, all of that stuff for that 7 days there. And then another cool incorporation here that we did here is we have our axles, right? And obviously on the moon, it's rough terrain. They're going to be bouncing around a lot. And so we...
Oh, you have them recessed in. Okay. I can see that.
If you can tell on the inside there, we have a spring actually.
That's
and,
nice. So
yeah, and it's bouncy as you can tell.
So it's like shock absorbers, yeah.
Exactly. And we were kind of our inspiration for that is like what you find on control arms on vehicles, how it has that spring there, and a hinge, pivot hinge, and whatnot. And something that we thought about here as well. We're very limited by our dimensions here, and obviously our wheels stick out a lot. And if our wheels stuck out like that all the time, that would break our dimension rule that we have to follow here. So kind of what we incorporated here is you can lower these wheels. You can take the spring out, or in a real model, you might want to use an airbag instead, simply because it's easier, I guess. But now that we don't have a spring in there anymore, now this wheel simply folds up all the way, and it just
So question is, so is that something you're expecting the astronauts to do? Because how will they get under there to raise the wheels?
We plan something mechanical.
Right. So in our model, obviously for purposes right now, we just use a spring because that's easiest. But in a real model, we would like to incorporate an airbag system somehow. On a lot of like motor homes, people install aftermarket airbag systems, or even on big trucks hauling fifth wheels. You have these airbags connected to the rear axle where they inflate and kind of give that rear suspension more strength.
Oh, I see what you're saying.
And you have the remote, and you can deflate those airbags, which just releases the air in them, and then they get flat. And obviously, our system, the wheels would completely hide up into the trailer. And the trailer would be completely flat with the ground.
Yeah. No, that's great because you're using technology that already exists on here. That's great.
Right. We're hoping that for a real model, it would be completely automatic like that. And obviously with an airbag, unlike a spring, they wouldn't have to go and take it out. You just press a button and it deflates. It's gone. Out of sight, out of mind kind of thing. And when they're ready to go, we would have to incorporate a compressor somehow, an air compressor to fill up these airbags, stealing air from the inside of the camper somehow. That we haven't dive too deep into, but that will be a constraint of this design idea, but I'm sure we can get that done.
Okay. No, it looks real good. I like how the sides come out.
What do you think of them storing everything on the bottom, that it actually goes into the floor?
No, I like that because what happens then is as they raise the top, everything comes up. So it makes it a lot easier for them to store as opposed to moving stuff from one room to another. So they're using that height and then raising things up.
That's awesome. So the only other question I had, Nancy, I want you to look at is where there are hatches.
Right.
Okay.
So that was our space ports. If you want to, I'll take a moment for that real quick. We have our spacesuit ports on the back here.
Okay.
These are just like sockets we made just to illustrate that. Hey, this is the piece that goes on the back of the suit, and then this is the connect. You see the socket here.
So what you may want to do is look at the spacesuit dimensions in relation to how you're going to make this. Because remember, you have 2 meters by 1.5 by 1.5, And then
Right.
just do some math to look at the size of the spacesuit to make sure you can actually fit two there. Because the spacesuit by itself it's more than just the spacesuits. You need that whole back of the spacesuits for the astronauts to come in.
Right. Funny enough that you say that is these are actually already to scale. Everything, this whole camper is 1 inch equals 1 foot is the entire scale of the camper. And we did research on this, and this is the back piece that goes on the back of it. And it's already to
All right, they've done the research. That is very good. Nice.
Absolutely. And we did the same thing with the hatch as well. On the slideshow that you guys have given us, you give dimensions of the hatch. And that's exactly what we did here. This hatch is to scale as well. And we wanted to know your input on, we put our hatch on our roof. And we wanted to know what you thought about that.
So first tell her you're going to be hooked up to a vehicle, right?
Right. So for our design, we would need to be, this camper has a standard hitch on it that uses a tongue, obviously. So we would need a vehicle that has a tongue on it that hooks up to that hitch. And on the presentation that you guys have given us, it shows that these vehicles, the drivers are already in a spacesuit. This vehicle they're driving is not sealed. And so our idea here is when they're done driving the camper around, they park it where they need to be, they can simply get off of the vehicle, walk up to the spacesuit port on our camper and hook up their suit to it. There's no need for them to get inside the hatch because our idea here is they only need the hatch for the beginning, or sorry, the end of the mission when they get back and they need to get things out of the camper.
Okay, because I guess so. Your assumption is they're going to be driving it outside. Because I think with the suit port, the thinking there is they will be getting into it from outside.
Absolutely, that is what we.
Yeah, and I think having a hatch on top. I didn't know they needed another. I know they needed a small airlock for samples. I didn't think we had to have another hatch because if you're going to have.
To connect to the
connect to the lunar module.
Right.
It was
in the slideshow, it says that we need a hatch that is able to make a hard seal and connect to a permanent lunar base already existing.
Okay.
And we did have a system for connecting that. If you're familiar with the IDSS.
Okay, so yeah, I'm trying to figure out how attaching to the lunar habitat from the top is gonna work because the hatch is because Flo, isn't that hatch for them to go from here to the lunar habitat?
Yes, and that's why I was worried that it was on the top.
Yeah, I don't know how that would work because then think about it, they'd have to go in through the top, go through the crawl space to get into lunar habitat. So having it on top seems difficult, I think.
Okay.
So you're okay with the spacesuits, the astronauts with the lunar vehicle and the spacesuits going into your thing. They don't need the hatch, but the hatch is not for that. The hatch is for linking up to the lunar habitat, the more permanent lunar habitat. Does that make sense?
Right. So does this mean that they're going to be using this camper? We were kind of under the assumption that this camper would only be used when they were going out and away from the main lunar base. So it kind of sounds like, please correct me if I'm wrong, but it sounds like you're saying they're going to be using this camper even when not on a mission outside of the base.
No,
I
think they're going to use it when they are only outside, when it's hooked up to the lunar vehicle. What were you going to say, Nancy?
Yeah, it says conduct to the habitat when not in use. So the question we have to ask Glenn is, for that docking, what will we be using it for? So it looks like they want to dock from the top. And a lot of times when you're docking, it's for recharging and different things. So, let us check with Glenn on that. And see.
Right. We did email, I believe we emailed Flo about this a while back, and I believe Flo forwarded it to Glenn, if I remember correctly. And I'm not sure if Glenn had an issue with that, but yeah, absolutely. We would love to hear feedback on that.
Okay.
Yeah, because if it docks to the lunar habitat, then they can clean it. They can they can get resupply it and everything. So I can't, especially if the astronauts are in a lunar vehicle they're exposed and they're in their spacesuits. They're gonna definitely need to clean this up and attach it to the lunar habitat. So
Okay, so I found here it says when the 5 to 7 day mission is complete, the crew will come back to the lunar habitat and will need to remove the dirty water, poop, and put in fresh food and clean up for the next mission. This means they need a hatch that allows them to attach to the lunar habitat. So the hatch is a way for them to go in and out. So here's what I would propose. If you're going to have the hatch on top, then you need to explain how that hatch will connect to the habitat.
Okay.
If you can say you know this is the method, that'll go a long way, because I think most of us are assuming the hatch is along the side and it'll connect because so they can come in and out. But if you think the top is the best way, explain. The key thing is explain how the hatch will then connect to the habitat.
Sure.
Okay.
Our thoughts on that currently is we just pictured them with the main lunar base. Obviously, it's not a real place yet. It's kind of a fictional place at the current. And we were kind of imagining to where they kind of have like a how do I put this? Kind of like a bay where they can where it can go in, and that bay obviously has a roof. And then with that bay on top, they have a system that comes down and creates a seal on that hatch. So basically, almost like a pull-through bay. I know. Okay. If you can imagine a car wash, they drive through, they stop, they're able to hook up to the main base whenever they need to go. They can just drive on through and keep going. That's kind of what we were thinking there on that.
I would, we'll chat with Glenn with that, but I think either way, as long as you describe it, it is different, but I'm not saying it's not correct, but it is different from what we've seen. And as long as you can explain it, which you just did, how you believe it'll attach, that should conceivably work.
and actually, one of our projects one year was making a lunar habitat with a garage, and that's
okay.
So it could go into the garage.
There you go.
Right, but you have to make sure you explain that, as Nancy says, because otherwise we're going to say, how are they going to get in and out?
Right, absolutely. And what's kind of nice here is obviously this main lunar base obviously isn't a real place yet, and so this kind of I feel like this gives us a little more wiggle room on what we're doing here, which is another reason why we put the hatch in a not so common place. I don't.
Okay.
Right. You get what I'm saying.
Yeah. No, I like it if it's going to be usable, and you're using all the other sides for other things. So where else can you put the hatch?
Right. And that was exactly our thought process. Well, all of our others have a use already.
Yeah. So while we have Nancy here, do you have any other questions?
Yeah.
I do have one question. So we for materials, we were planning on using an aluminum alloy that has been used in space and is currently used in the aerospace industry.
Okay.
So I believe it was designated 2219-6061 aluminum alloy. There are some variations of it, but I have the full, composition of it right here. I won't bore you with the details on it, but have you heard of that material?
6061 I have heard of. 6061 is the type of material we use. The fact that you say it's an aluminum alloy, and if you found a place where it says it's been used, in space vehicles or outside, that's perfectly fine. The key thing is research the properties with regards to temperature, because remember, it's going to be out in the vacuum, exposed. As long as it meets those requirements, then it sounds perfectly good material.
And I did do the research on that. And then one more question on material. So with our hard walls, we will need an insulator for that. But I thought of aerogel. It's an extremely light material, if you're familiar with that.
Yep.
There are sheets that they have that are specifically designed for insulation because they don't have they don't have great heat transfer, so it insulates the inside of it very well. So,
Yeah.
do you have any comments on that at all, or?
No, I think aerogel is a good material. I don't know the composition, but as long as you do some research and you explain where you're going to put it and things like that, that sounds like a good approach too.
Okay. And then I guess just one final one. We were thinking about using silicone for our seals and stuff for, like, say, our hatch and stuff when it docks, or
Okay.
for some of our, I guess, just wall seals and stuff. Has that been used before on stuff?
Well, I know I use silicone in my house. I don't know what its properties are. My concern is just see its behavior when it gets real cold, when you're going to be out there. So again, just do your research, and if it shows it works well in the cold, and especially the temperature extremes, then you should be okay, because that's the thing you want to look at.
Okay. Okay, thank you.
Right. Okay, sounds great.
Appreciate your feedback.
Yeah. Thank you so much, Nancy. That was a big help, right, guys? But I love your design, so
Yes,
keep it
looks
up.
neat.
It does. All right, so you can get back to class, though it's almost the end of the day, right?
Yeah.
I
Nice
appreciate
work.
you waiting all this time. Thank you so much. So,
Thank you guys.
have a good afternoon.
Okay, bye guys.
Thank you.
Bye
You too.
bye. I'm going to